Okay.
Huh?
I think it was one day next year was
Okay, so
Actually, I don't know.
so let's talk about 28, probably 28, 29. Because you're pretty likely to see a question like that on the test tomorrow. Okay? So here's what you got on 28. So you're given the acceleration on the moon, it has smaller mass, you have a smaller weaker gravitational field. What is the length of the pendulum whose period on the moon matches the period of a 2-meter long pendulum on Earth? So there's a couple of options you could do. No matter what, you have to start with the idea that the period equals 2 pi times the square root of L over G. Okay? So one option is that you could do smash mouth physics. So you're told that on 28, it's a 2-meter long pendulum, and you know what the gravitational acceleration is on Earth. So you can go, okay, 2 pi, the length is 2 meters, and you know that g is 9.8 meters per second squared, okay? And you can figure out what that period is on smash mouth physics. Okay, you can find the value of that t. Okay, you can figure out how long that's going to be because you know everything. And the whole key to that is says, okay, what is the length of the pendulum whose period on the moon matches that? So this would be the period on Earth. Okay? So then you're going to take that exact same number to the moon. And then you're going to go, okay, period on the moon. Now I know what that number is. Okay? 0.7 seconds, whatever it is. Okay, now you're going to have that number. And then put that into 2 pi times the square root of L over G. Again, now you're going to know what the period of the moon is. You know what G is on the moon. They gave you that in the problem. Solve that for L. Okay? It's smash mouth physics, but it works. Okay? So you find the period of that pendulum on Earth, set that same period on the moon, do the algebra, find the value of the length. Now, here's the other thing that you could do. Okay, here's option number 2. So if you solve that for L, you're going to get L equals gt squared divided by 4 pi squared. Okay, so you just do the algebra. If you solve that equation for L, okay, this is what you're going to have. Gt squared divided by 4 pi squared. Okay, that's what you're going to have. So this is where you can do a little bit of algebra. So this is going to be the length on the moon. Well, this has to be the period on the Earth. So if you come in here and go, okay, well, that's going to be g times, okay, and now you're going to put in how do you calculate the period on the Earth. Oh, that's going to be 2 pi times the square root of L on the Earth divided by G on the Earth. And then that quantity is going to get squared. Okay? And that's going to be L on the moon divided by 4 pi squared. Okay? So now, once you square that, then you've got G on the moon, and then you've got 4 pi squared, L on the Earth, G on the Earth, divided by 4 pi squared. Your 4 pi squareds cancel out. It makes the, like I said, you have to pay more on the front end for the algebra, but then at the end, you just take G on the moon times the length on the Earth divided by G on the Earth, boom, there you go. So no matter how you do it, your answer on 28 should be between 0.1 and 0.4 meters. Okay? Wyatt, did that get a pencil drop?
It sure did. I got the.
You got what?
I got the right answer.
Okay, you dropped your pencil like you had an answer of 5 meters.
You're just testing gravity to make sure.
Still works?
Yeah.
Gravity stuff? We're
I
good?
thought you said 1 meter, it's at 0.4.
And 29, you can do the same thing. Okay? 29, you can do the exact same thing. Do the substitution for that. So I don't care how you do it, but just understand how you can work a problem like 28 or 29. Okay? Just saying. Let me see what else. On question 44, where you have to draw the graph. So this could get a little bit sketchy, but not bad. So on 44, you want to figure out the spring constant. Okay, well, you know, F equals Kx, right? And the force is mg, okay? And that's K times however far it gets elongated, okay? That's the simple way to do that. So you know the m and the g, you know the value of the length, so you can figure out the value of the k. So on 44a, because if that's wrong, everything's going to be wrong. Your answer to 44a should be around the legal drinking age.
Hey. Or about, what about a legal age?
Within one.
What if we say like, what is the legal age?
Like 1.0.
So we're talking like
That's not
in
what
the
they
UK. It's like
No, in the United States. In your reality.
What if our answer was like 90?
Would you say that it was in like 1.4
I can
years?
live with that. That's pretty close
Wait,
to
which
the
one?
legal drinking age.
Okay.
Wait,
13 would be way off.
oh, nice try, buddy.
I mean, technically, wait, where?
No, I got
44?
No, where did I get your
Drinking age in Russia. You should have seen me that before.
Oh, we're talking about A.
Okay.
Drinking age in Russia is like.
On 46. So 46 gets a little bit tricky if you don't do some algebra. Okay? So, again, you want to find the value of k, right? So, on 46a, that value of k should be in the mid-20s.
Nice.
Okay?
Oh, nice.
That value should be in the mid-20s. Because if that's wrong, everything's going to be wrong. Now, on 48, let's talk about 48. So, it's Hooke's law. So, you know, force equals k times a change in length, which is mg, right? Now, stay with me through the algebra on this one, because this is really. So if I solve this for mass, I get k delta L over g equals the mass. Okay? All I did was start with Hooke's law, and I solved it for mass. Because here's the problem on 48, is that you don't have the mass. Okay? But yet they still want you to find the frequency. But here's the whole key. It's an oscillating mass, right? So frequency is 1 over 2 pi times the square root of k over m. Right?
Right.
Go with this.
Yeah, we know.
So, but mass, though, equals k delta L over g. So I can substitute k delta L over g.
The K's die.
So what happens to the value of k?
They die.
Cancels out. So what are you left with?
Or G over.
1 over 2 pi times the square root of
G over L.
No, because it's G over L. So
That's right hand.
Now, what units should you get out of this?
Wait, is it
Whatever
seconds?
seconds.
Oh,
This is seconds.
Whatever
Seconds.
seconds. Hertz.
So hertz.
So you get meters per second squared, right? Divided by meters. So you get the square root of 1 over second squared, which is frequency. So your answer to 48 should make an not bad GPA.
Scholarship?
Maybe, depends on the school.
Okay.
And that is trash.
My GPA should go down.
Oh, probably by about 3 points.
I hope it does.
Hey, that's still not me.
The way it's going right now, I don't have faith.
Okay.
Are we talking about how much better KU is?
He said
So
you.
it's easy. Supposed to be the easiest unit. Have you gotten it?
Oh, 'cause it's your birthday?
So did my
What's his
my
birthday?
also had a class.
The way that took us out was like, this might be it.
I don't know how. He knows.
I didn't want it to
Is
be.
that he's a name?
Okay.
It is.
Anything else? If you want to hold on to that assignment and hand it in tomorrow, you can. Right? If you're done and you want to hand it in, that's what we're
Why would I not try to do? Once I lose it.
Just study, man.
How are you gonna lose it?
I've never had
My
one.
graph is the 3.5. Is that what you got? Yeah.
Hey, that's my
Is it-
birthday.
I didn't say that.
It's hertz or whatever. It's just frequency, so however you want to break that. I guess a minute today. I am, yeah. I was like, I thought about bringing it. Oh my god, look. I'm not. No, I'm not.
There's no math in it. It's
He just is sick.
What are you gonna
I think it's like a
27?
Yeah, the ABC.
I didn't do a 27.
27 on the problem? Whoa. Big Mike, what do you got on 27?
Oh, the problems? Like, the questions?
Yeah.
Oh, I got B.
Okay.
Whew! Okay.
27 on the question.
Oh, B.
Alright, I like
I
that.
thought you said the problems.
Yeah, my bad, my bad.
The max of it is at 4.
I thought we already went over.
And the low is at 2. Yeah, our graphs are entirely the same except for your
You guys need to grade this class.
It's literally working. Yeah, I just saw. Oh, I guess I said.
I got a lot of
Yeah, you're gonna need
Stop.
tweezers.
I don't think we have the
Use staples. So wait,
Oh, it's full of staples.
Set down.
It was literally just working.
Yeah, I just used it and it worked. And then I tried it on my
Funny
paper.
how it stops
and
working when mine gets up there.
Yeah, now it works.
Hey,
The staples worked out.
Hey, funny how I just saved my paper, Ryan.
Funny how it stops working when Michael's good.
Funny how I just saved my paper.
They're not being bad. The bottom.
Funny how something goes wrong with Michael's good.
So, for like birds that can't fly. Wouldn't it be more like
It
you
shadows,
think
yeah.
that
All the way
more
all the way
everything
back down.
have
Because that's your
probably
one.
I don't think they
It's
know.
causing just like
Probably
maybe
never lost that ever.
I don't think we have.
Well,
one.
penguins
Yeah,
have
no, I feel like yeah.
Sure they do.
Someone else to explain.
Did you watch Penguin Madagascar? They flew. They built a plane.
Oh, they built a plane. Oh, did humans fly? No, but we can build planes.
Did you see them jump out of the they're hopping planes landing on a food truck?
Yeah, but that's not fun.
Wait, wait, did you see them fly?
King Graham's dad.
Upper
King Graham's dad fly.
No, what kind of guys do?
He builds planes.
Okay.
He flies.
Oh, like down.
So
Yes.
this is one, so from here to here, going up, down and back, is one.
Especially because there's a lot of diagrams visuals even on the draw. Like,
So
Hey, all I need to know is my hey, all I need is my trusty right.
yeah.
But we don't know where actually.
also, but there's a lot of stuff that you remember.
Which one?
48.
I don't know what
Your notebook?
Okay, that's gonna be half
It's
T,
an AP bio.
and then that's gonna be a quarter T, and that's
Where
gonna
did
be.
it say not about that?
So you can find 3/4 seconds.
So what about
What does that say? The, like, square thing and then the
Oh, I've
3.
got so much advice.
Wait, for the graph on that one problem that we had to do, did you write like t over the number, or did you actually like write it?
I wrote the number and then under it I put 2. And then, so I did like the number and then half the number for 2 over 2. And then after that I did like 2 t over 2.
Because I wrote like the number for the period and then I just wrote just t over 2. Should I answer that's fine?
It's probably.
Oh, my hand.
I feel like it would be.
Got Donald Trump on.
Okay. Okay, so let's just say I gave you this problem hypothetically on the test. Hypothetically. Okay? So you have a spring constant, K is 100 newtons per meter, its amplitude is 0.1, the oscillating mass is 1 kilogram. Okay? This is about the type of springs that you all have dealt with in this lab. Okay? My springs have a K value of around 80. This has a little bit, it's around 100, so it makes the math a little bit simpler. So you should be able to find period frequency, and on frequency I want that as a numeric value and as a fraction of pi. The frequency, and then find V max, and then verify that K max equals U max. And then find the position at time equals 0, 1/4 t, and 1/2 t. So on the test, and it's going to play out the same way. You're going to start with it being at the top of its oscillation, and then it's going to fall. Okay? So I'm not going to talk for a while. Try and work the problem. Yeah, frequency, I want an actual number, and then also as a function expressed in terms of time. No, just frequency.
In the parentheses for frequency.
As a numerical value and then fraction of pi.
Oh, okay.
Oh, you
Is that stapler just shock crap?
Yeah, it's kind of weird.
It's
It falls down, so you have to kind of push it back up to.
Well, I know that. I'm just talking about the one that's hanging. 'Cause I think I might have to get a new one.
Yeah, I think this might.
The hang one works. You kind of just have to like sometimes the staples fall out, so you have to like push them back.
That's no different.
It kind of makes me sad because I've had that stapler.
You looked at me like
This is your paper.
No, you looked at me like this.
Xavier has to.
You get 1.9.
You do.
I'm 75% sure I have.
Yeah.
No.
You rip my page.
But
0 point.
I can't guarantee. I'm pretty sure I know that. But it's been a while.
Of 1
They said this.
divided by 100
No, it's just a. It's 1 over 100.
Oh, I forgot a 0.
to the square root times 2 pi.
What did you get?
I did a little one.
Oh, you got the right thing.
0.2. Don't ask.
You know what? You capitalize the you're right.
And like I said, like on this V max equaling 2 pi FA, any kind of random equations you're going to need are going to be on the front of the test. Okay? That's where they're going to be.
By the way, 10 over 2.
So that's going to be answers.
10 over 2 pi is 5 over 5. Actually, little numbers.
Okay.
Yeah.
if you want to get them all coming. I mean, I really will. I was like, what happened? I was
Saving it for a rainy day.
okay, let me know when that rainy day hits. Because I am literally, I'm just going to turn my head, what happened? I don't know. I look back, Michael's on the ground. I don't know what happened.
Wait, what does he mean by verify? Just show
proof.
mathematically that they're equal. Oh, okay. Just have to hit check mark and be like, yeah. They're
Are
right.
those two like really strong magnets stuck together?
I found him like that. I found him.
I can confirm he did find it.
I did find. He can confirm I found him.
I doubt he would find it like that.
I
don't
found
think,
them like that.
I don't
promise
think
you
you would
that's
leave them
funny.
like that, would you, Mr.
I
Mark?
found them like that, and I was
Mr.
trying to
Durkin?
separate them. I think that was Cooper. I think that was his like. That's his class. Cooper. Yeah, that was Cooper. Who's Cooper? Oh, what are you?
Cooper Hoarder.
Yeah, see, that was him, not me. I'm gonna try to separate them, and I
Okay.
I can't.
So let's kind of make sure everybody's cool with this. Huh? No. I just want to make sure everybody's starting on the same foot. So how do you define a period of the oscillation?
5 over 5.
Square root of
M over K.
M over K, right?
Okay, for your frequency in terms of pi.
So I purposely picked these numbers fairly simple. So you got 2 pi times the square root of your mass, which is 1. And then the K value is 100 newtons per meter. Okay? So you get the square. This is where it's handy to kind of step back and like, hey, maybe you don't have to live by your calculator. What's the square root of 1 over 100? 1/10, right? So you have 2 pi times 1/10, which simplifies to 4 pi over 5,
I over 5.
right?
Right.
Okay? So if my period is pi over 5, which you can put mathematically, you can take pi and divide it by 5, okay? And you, what do you get? Like 0 less than 1. What do you get for the period? 0.628 seconds. Okay? So that's the value of t, right? So frequency then is going to be the inverse of that. And so that's why I said in terms of a number and in terms of pi. So the numeric value would be the inverse of 0.628. But in terms of pi, it would just be what?
5 over 5.
5 over pi. Okay? So this is going to be 5 over pi, okay? Which is going to be also equal that raw number when you take 0.628 and take the inverse of that. Everybody cool with that? Everybody see what we've got? All right. Now, to get V max, okay, there's a couple of ways that you can get V max. One option for V max is this one, which is 2 pi f times the amplitude, right? Cool. So I got 2 pi, and this is why it's sometimes handy to read frequency in terms of pi, because sometimes it makes the math a little bit easier. So so the frequency in terms of pi is what?
5 over 5.
Huh?
5 over 5.
5 over pi, right? Okay? It makes the math a little bit simpler. And then, multiplied by that amplitude, the amplitude is 0.1 meter. So, conveniently, what do you get as your max then? Huh?
1 meter per second.
1 meter per second. Because the pi is going to cancel out. And then you have 2 times 5, which is 10. 10 times 0.1 is 1.
Yeah.
0.9.
Okay?
I know, like,
Now, where is V max going to occur?
In the middle.
The middle of the oscillation, right? So that's where V max is going to occur. Now, you can also find V max by the square root of K over M times A. Right? It's another way to calculate Vmax. So hopefully we get the same answer. So I've got my K value, which is 100 newtons per meter. My mass was 1 kilogram. My amplitude was 0.1.
I over 5
meters. I get the exact same answer. Right? So there's 2 different ways you can calculate Vmax. One off K over M times your amplitude. The other one is 2 pi Fa. Now, what's another way that I can express 2 pi frequency?
Omega.
I could also do omega A. Do the units still work out? Because omega is in radians per second, amplitude is in. Now, no matter how I calculate this, if I double my amplitude, what's that going to do to Vmax? Double. If I double my amplitude, what's that going to do to the period of the oscillation?
Double? Oh, the period?
It's not. I have not.
Look at how you calculate the period of the oscillation. If I double the amplitude, what's going to happen to the period of the oscillation? Absolutely nothing. Okay? Because where do you put the amplitude in the calculation?
There's no amplitude.
Nowhere.
Okay? All right. So I got my Vmax. Knowing Vmax, what else could I find?
K-max.
I could find Kmax.
Yeah.
Right? Kmax is going to be 1/2 M Vmax squared. 1/2 mass is 1 kilogram. 1 meter per second squared. I made this as easy as I possibly can. You're going to get
1/2.
half a joule. Right? With that. And again, where is that going to happen?
Equilibrium.
Equilibrium point. Okay, middle of the oscillation. So, what would the position time graph look like? Start up here at that amplitude of, what did I say the amplitude was? 0.1. So the period of the oscillation was what, 0.628 seconds? So this would be like 0.628 seconds. There's time 0. So if I start here, how long is it, where is it going to be at 0.628 seconds? Back to that same point or at the bottom?
Same point. Top.
Same point top? So something like this. Okay? At this point, at these points, okay? It's in the middle of the oscillation. What do you know about the velocity? Max. And so technically this line should probably be more like that. So when you draw that tangent line, because what is the slope of your position time graph? Velocity. So if I said, hey, where are you going to find the steepest tangent line on this graph? Where are you going to look? Middle of it, because that's when I have the biggest velocity. Okay. So I got this. Cool. I want to verify that Kmax equals Umax. So what could I do there?
1/2 K squared equals 1/2 FE squared.
So Umax is going to equal 1/2 K A squared, right? So I take 1/2 times my K value, which was 100. I multiply that by 0.1 meters squared, and you get 0.5 joules. Cool. Okay? So all I did is just prove that K max equals U max. So at any point in time, what do the two energies have to add up to? 0.5, right? At any point, the two energies have to add up to 0.5.
Could be like,
Okay. Now, I want to find the position at time equals 0, 1/4 t, and 1/2 t. Okay? And again, so this one is actually on your equation sheet. But position is a function of a cosine theta, 2 pi t over t. Sometimes you'll see it written as 2 pi t times 1 over t means the same thing. Okay? Some people like to think of it that way. If you're going to do this, what mode does your calculator have to be in? Radian mode. That has to be in radian mode. What?
What's the difference between the cosine and the sine one? Like there's a cosine one and there's one with sine. I don't know.
One, because the sine is velocity, cosine is position.
it says about.
Yeah, it's just.
I'm only use the cosine one.
Only use the cosine.
Okay.
Never use the sine one.
No. On how I'm going to define the system. How I'm going to define the system. Always use the cosine one. Okay. All right. So here's the story. So at this one, you have your amplitude of 0.10 meters. Got the cosine now. You can do smash mouth physics, or you can just put 0 over 2, or over whatever the t is. So you're taking the cosine of 0. What's the cosine of 0? 1. 1 times 0.1, that gets you your starting position, which means you're starting up here at 0.1. Okay? So you go to 1/4 t. So if you do 1/4 t, when you look at, even if you were to just look at your graph, let's say, I don't know, maybe not sure. Well, where is it going to be at the bottom of the oscillation in terms of t? Yeah, so that's going to be t over 2. So by logic, where should it be at 1/4 t? Should be at that equilibrium fourth mark of 1/4 t. So you can either look at your graph and go, oh, it's going to be 0, or you can come in here and go, oh, that's the cosine of 2 pi, and then you've got 1/4 t over t. The t's cancel out. Basically, that reduces down to the cosine of pi over 2 times your amplitude. I don't care how you get to that point, okay? But the beauty of this function is that it tells you where you are at any point on that graph. Okay. What is the slope of your position time graph going to give you? Velocity. So now, if this is how my position time graph is going to play out, starting up here and going down, what's my velocity time graph going to look like? So on your velocity time graph, that's going to start where? At 0. Is it going to go up? Or is it going to go down?
Down.
Well, look at your position time graph. What's the sign of your slopes, your tangent lines on your position time graph at the beginning? Negative values, right? So at 1/4 t, that's when you're going to have your biggest negative slope. Okay? So if you start here at 0, and that's t over 4, and that's t over 2, and that's 3t over 4, and then t. Okay? So at t over 4, you're going to do one of two things. You're either going to have your maximum positive velocity, or you're going to have your maximum negative velocity. It's got to be one of the two. So what's it going to be? Yeah, because if you look at how your tangent lines go, and that's how it's defined. So it's going to go to some big negative value now at t over 2.